Hello everybody, this is Avantik here. Welcome to the next video in the series. We'll be learning about NumPy here, and this is kind of the essential NumPy that is required for you to learn machine learning. Okay, and throughout in this essential NumPy contents, we'll learn about what is NumPy, initialization and creation of NumPy, accessing, concatenation, splitting, shape, size and ending, reshaping, changing dimensions, NumPy utility functions and broadcasting. So first, let's start with introduction of NumPy. NumPy is a mathematical library. Machine learning internally is very mathematical intensive. Okay, and you need a library which can do this mathematical computation really fast, and that is why NumPy comes into picture. It is a homogeneous data structure. That means unlike your list, which is a referenced data structure. Okay, because of which it can store different type of data. Let's see, this is your Python list, right? Okay, and these are like different contents here. Okay, so this is pointing to 2.0. This is the first data. This is pointing to hello. This is pointing to hi. This is pointing to 7, right? So you have this different type of data here. Okay, so this is how list does it. It actually references. Okay, list actually references here, and that is what makes allows it to store data of heterogeneous types. Okay, whereas NumPy stores data in memory, and that is what gives the performance to it, right? So if your NumPy is there and it stores only integers, it will be 2.5, 2.7, 3.2, 7.1. It will store data of same type. Okay, internally it's all written in C++. That is what boosts the performance. Okay, it is implemented and extensively, the scikit-learn library, it's implemented and extensively using NumPy internally. Okay, and of course, as we discussed earlier, it is way faster than your list. So every computation that you want to do in machine learning, make sure you are using NumPy for that, not regular lists. Okay, now let's understand how do you initialize a NumPy data structure. Okay, and size is a very important part of it. Most of the APIs would need size as an argument, and you will be passing size as a tuple. Okay, we have zeros. Let's see one by one. So we have zeros here, np.zeros 2,2. Okay, you can see this is, you are passing size as a tuple, and when you give here 2,2, what you are telling here, you are creating a 2x2 NumPy array with all value initialized to zeros. Okay, and similarly you can do for ones also. Okay, so create a NumPy data set. First you have to import it. Okay, then you do np.ones and you mention the size here 3,3, right? You are creating a 3x3 matrix. Okay, then you have np arrange, similar to Python's range, right? You have arrange. 2 is the starting point, 10 is the ending point, and of course 10 is not inclusive. That's why you see 2, 3, 4, 5, 6, 7, 8, 9. Then you have np arrange. 10 is the starting point, 2 is the ending point, and this is the step size -1, so it will reduce by -1 every time. Then you have length space. Between 0 to 10 you are generating 11 numbers equally spaced, so that is why you see data like this, length space. Then you have log space. So between 2 and 4, with 4 exclusive, you will be generating basically you come between 2 and 3, it is generating 8 numbers, right? 2 and 3, 8 numbers. One of them will be 2 raised to the power 0, right? And one of them will be 2, next will be 2 point something, right? So if we do it, how do we understand this log space? Okay, np dot first do length space between 2 and 4, 8, right? You will see these values. So np dot log space 2, 4, 8, this value. So this is 2 raised to the this is your 2 raised to the power 10 raised to the power 2, right? That is what 100 is. 10 raised to the power 2.285, right? That is what this value is, right? How do you know that? You can use calculator for this. Okay, 10 raised to the power 2.28, right? You can see it's coming, with 2.28 only it's coming like this, right? Okay, so this is 2.28, 10 raised to the power 2.2851, this is the value. 10 raised to the power 2.5, this is the value, and thus in the last 10 raised to the power 4, this is the value, right? That's what happens over here, right? That is your log space, right? Then you want to generate a random number using NumPy, and this is one of the common operation that you'll do. Okay, np random.rand, if you have 2, 2, 2. So what it is doing, it is actually generating random numbers between 0 and 1 of size 2 cross 2 cross 2, actually cube, right? It is generating those random numbers. Randint is another useful utility. It is generating random numbers between 0 to 10 with 10 exclusive. So 0 to 9 is a random and size is 5 cross 5. So this is what whole numbers it generates. It's very useful. Now, as far as accessing of NumPy data structure is concerned, say you have this, these your actual NumPy array, it is 5 cross 5, and you do colon comma colon. That means all the rows, all the columns. This is equivalent to printing day itself. If you do colon 1, it means all the rows, only one first column. That's this okay, that this column it's trying to access, right? Then you have colon 1 to 4, all the rows, column 1 to 4 with 4 rows after 1, 2, 3. So these 3 columns will be printed. As you can see, this is the output. 1 colon 4, 1 colon 4. These first 1 to 4 rows, 1 to, so this is the data that will be extracted. Okay, so this was about accessing the NumPy data structure. This was about creating them. Now let's understand how to actually concat various different NumPy data structures. Okay, the first API is a concat. Okay, let's understand how does concat word. Okay, so let's say you have this array A, okay, and B is this np.zeros, right? And you have 3 cross 3, right? So this is your A and that's your B. Okay, so what you want to do now is you basically want to do A plus you want to concat these values, right? And you do np dot concatenate A comma B, right? So you can see here by default it is vertically sitting on each other, right? This is the first guy, this is the next other guy, so it's sitting on this guy vertically. Okay, so this is the first option, and if you give xs is equal to 1, it is horizontally. So by default it is xs 0. So xs 0 is this is your xs 0 and this is your xs 1, right? Okay, of course it's not limited to only this dimension. You have xs 2, 3, depends on the data structure, it will keep on increasing, but this is 0, this is 1. Okay, so this is the first way to add data. So concatenation, by default it will be vertically concatenating. If you mention the x's, it will be doing horizontally. So of course you have a better API to do that. Okay, then you have vstack and hstack. Okay, vstack means vertical stacking. So this is A, this is B, it's V stacking, this is what you see, and this is hstacking, horizontal stacking. This is similar to your concat, just that you don't have to pass the excess information over here. Okay, so if it is two-dimensional data, vstack and hstack works pretty well. And the point to remember here is, when you are doing vstacking, the number of columns should be same. When you are doing hstacking, number of rows should be same. Okay, since you're comfortable now, concatenating different different NumPy data structures, now we'll be splitting one NumPy data structure. Okay, so this is what the option is: vsplit and hsplit that we will commonly use. This is vsplit. This is a data structure D. Okay, and you're mentioning 2. vsplit means splitting the vertical axis. So this is your vertical axis, isn't it? This is your vertical axis, right? So if you are doing vsplit 2, that means 1 2, so it will split from here, right? That's why you can see it is returning 2 NumPy arrays, D1 which is the first part, D2 which is the second part. Okay, then you have shape, size and ending. This is another useful utility. So this is your NumPy data structure, and if you do endim actually tells you number of dimensions. Right, here you can see this is 2D, so dimension is 2, and d.shape, it is giving you basically the shape of the data structure. Like it is 6 cross 6. Okay, then you have d.size, it is giving a total number of elements here, d.size. Okay, so these are some of the basic you can see here, this is not the function, these are attribute properties, and this basically tells you something about the data structure, very commonly used. In machine learning, many times shape creates problems, so using this utility you might want to cross check the shape if it is in line what your algorithm is expecting. Okay, reshaping, as I was mentioning, is a very useful utility, and you'll need it very often. Okay, learning algorithm expects data in certain shape and dimension. Okay, so you need to use shape utility to understand what is the current dimension of the data structure. Okay, then use reshape to modify it how the algorithm is expecting. Using reshape utility, we can convert data into desired shape. but the desired dimension will also be of same size, right? That is what is important. You can reshape it, like for example, if you see this NumPy array which is one dimension, you are able to convert into one row here, right? You are converting here in the data structure into 2 columns, and -1 means derive the number of rows, so 3 cross 2 basically, right? So what's happening over here is the same data structure you're converting into 3 cross 2. What is important here, the size remains the same. This is 6, this is also 6, right? Similarly here, there is one data structure which is 4,8. Of course 8 for the 32, so of course any multiple of 32 is fine. So you're reshaping in 2 cross 16. This is what it becomes. Just one point here, -1 means derive the number of rows. If you write here 2 comma -1, it will be 2 is the number of rows and -1 is the number of columns. So derive it, so it will be 3 columns in that case. Now that we understand what is reshaping, we need to understand what is adding dimension means. Okay, as you can see here, this particular data structure A has one dimension, 6 comma. If you do a.endim, it will give you 1. Now you want to convert it to 2 dimension, primarily because 1 dimensional data is not accepted by learning algorithms. You need 2 dimensional data. So this is what it becomes. It converts the data into rows of columns. 2 means 2 columns and -1 means derive the number of rows, right? So you're adding dimension. Another way to add dimension is using this function np_access, np new access. A is this data structure. One way is you reshape the data into -1, 1. So 1 is the column and -1 is getting converted into 6. You can use np new access so that it adds 1 dimension here. Adding dimension by 1, okay, I mean if you are increasing the dimension by 1, you are not changing the size of the data structure, so you can add as many as you want. Okay, just to show, suppose you have A, this is how you are creating a NumPy array from a list 1 2 3 4 say 5. Okay, if you do a dot np dot new access comma np dot new access, fine, you're just adding the dimension here, right? If you do shape of it, you're getting 5,1,1. Okay, NumPy, the purpose of NumPy is to do mathematical computation faster, and there are a lot of things you have to do. You have to do linear algebra here, you have to do trigonometric functions here, you have to do a lot of mathematical operations here, you have to do a lot of statistical operation here. So it has huge list. I haven't mentioned the entire list here, but it's a huge list that it supports. And if you have a NumPy array like this A, and you want to sum all the values inside this NumPy array, you should use np.sum and pass A to that. It will do this. A warning, don't use Python functions on NumPy. I mean, of course, this is a small data structure, so you don't create any problem, but you can use timeit utility and see the performance difference. You will find NumPy data structure 100 times faster most of these occasions if the data is too large. Okay, similarly, if you want to find the max, np max A, right? So in this NumPy also a dot max, both are fine. Okay, so we can try a lot of these stuff. So one more thing before I proceed further, suppose a np dot random dot rand int 1 to 100 size 6,6. Okay, so you have this NumPy array with 6,6, and what you want to do here is you want to do the sum across xs1, np dot sum, pass this and pass this xs information 1. So you're doing sum across xs, right? If you want to do column wise, you pass it this np dot sum, and if you don't pass any of the xs information, it is treated as none and it will sum all the data here, right? So most of the utility you can use standard deviation, mean, cross product, dot product. You have all these operations. You can try out these. It's a huge list of operations. Now let's go to broadcasting, which is definitely one of the most interesting topic of NumPy. Before we do so, we have to understand few things, and this understanding here will be applicable to entire machine learning. So any data that you will come across in machine learning will have to be represented in a vector format, right? Suppose then this is one row. Okay, one row of data. This is second row of data. Each row of data will be represented in a vector format. Why that? What I mean is one row and number of column will be number of features. Okay, so this is age, this is salary, This is encoded gender, like male will be 0, female will be 1. This is latitude. Okay, some numbers. Basically, whatever data you have in the raw format, this is something what we saw in the previous slide, right? Data which is present in the raw format, like text, image, audio, and all that, those has to be converted into this vector format, right? So this is one vector format, this is one vector format, and the entire machine learning library understands data in this vector format. Okay, which is the first understanding we need to build. Okay, so broadcasting, what is this? It's a technique used by NumPy to do mathematical computation when the data structure is not of same size and dimension. Okay, I'll explain what I mean by that. Okay, so say we are creating a vector np.array. This is one array. Okay, now of course basic vector math says if the data structure is of same size, that means I have another array which is of same size and dimension, like 3, 4, 5. If you do a plus b, right, it is like element wise addition that is happening here, like 1 plus 3, 2 plus 4, element wise addition. Okay, so this is your vector maths here, right? So element by element operation is happening. But what happens when you do this? Right, something interesting actually. Let's understand, and we will use this diagram to understand it. So this is what our situation. We have this NumPy array and we have the scalar value, right? Fundamentally, it is not possible without broadcasting. What broadcasting is, it actually converts the scalar value into a vector of same size and dimension, and then it carries forward the operation. Okay, so you can see 5 is you can see the dotted data here. 5 is getting extended here like this. It is repeating the contents. That is what broadcasting is, and then the operation is happening. Fine. The next thing is you have this NumPy array of 3 cross 3 matrix. You have one dimensional array here, right? Array NP arrange 3. Now you want to do this operation, right? Even this operation is not possible because the size is different. Like the dimension, the shape, and the dimension, both are different. What you do here, you just repeat this content 0, 1, 2, 0, 1, 2, right? You are repeating, and you can see after repeating the size is same, then the operation is happening, right? So similarly here you have NP arrange 3, right? You are reshaping it to 3 rows and 1 column, right? 3 rows, 1, 2, 3, and 1 column, and you have NP range 3. So this is basically 3, 1. This is 3, right? You want to do operation between them. You can see this guy increases in this dimension, this guy increases in this dimension, then the sizes are same, and then the operation can happen. So what is that we are trying to understand here is, you can see, you have to understand that broadcasting will happen only when one of the dimension is 1 or the dimension does not exist. Let me explain it, what I mean. So say you have NP array 1, 2, 3, 4, 5, 6. B is equal to, this is 2 cross 3, right? Okay, A dot shape, and you have B dot shape, right? You have A dot shape and B dot shape. If you do this, we'll see an error that broadcasting failed. That's what. Operands could not be broadcast together with shape 2, 3 and 3, 3. That's because for broadcasting it is important that one of the dimension is 1, right? Only then it can repeat itself in that dimension, or the dimension does not exist. Okay. So that's the reason. So if you change this to 1 dimension, right? If you change this to this, okay, you can see 1, 3, 3, 3, and then the operation happens. Because if it is 1 dimension or no dimension, it can actually repeat itself. Okay, that was not the situation in this case, isn't it? 2, 3, 3, 3, and the operation cannot happen. So in this situation, what you have to do is we have to add certain dimensions so that wherever it is dissimilar, it can increase in that dimension. For example, last one is fine, but 2 and 3 is mismatch, right? So what I can do is A dot reshape 1, 2, 3, B dot reshape 3, see 1, so 3, that is fine. This guy will replicate in this dimension, and then 1, 3. Now the operation will happen, right? So what happened over here is broadcasting itself was not able to take care of this situation because it didn't know in which dimension it has to add. But so we manually have to do this. Okay. Now before we end this, one important point here, like if you have to calculate things like this, you have a pool of points here, right? So this is 1 point, 2 comma 3, 4 comma 5, 7 comma 8, like, and so many. And you have another smaller pool here, say 1 comma 1, 3 comma 2, right? You want to find out from this point which is the closest point among all of them, from this point which is the closest from all of them. You basically have to define all possible combinations, isn't it? So this is 2 cross 2, this is 3 cross 2, the same stuff, right? 2 cross 2 and almost similar. So what you do is you need to reshape it so that the operation happen, and whatever results show up, right? So I'll just change these things. 1 comma 1, this is the first stuff, and 3 comma 2, right? So here it is 2 comma 3, 4 comma 5, 7 comma 8, 7 comma 8, so 8 comma 2, 3 comma 2, right? This is the same data. Now what you are doing here is you are adding 1 to 2 and 3 2, right? So you find this. So this is plus, and in case you want to find the difference between them, this is this. So this is basically distance of this point from all of them. This is basically distance of this point from this point for all of them, this point for all of them, this point for all of them. That's why we have it like this here. Okay, so this is what is happening over here. Okay, so we have these two cases. This is A. What you have to find is you have to find the distance between this guy and this guy, right? This guy and this guy, this guy and this guy. These two pool of numbers, we want to find distance from this guy to all of this, distance from this guy to all of this. This is the data A and this is the B, and this is the shape of it. If you do 2 comma 1 comma 2, we're just reshaping it so that we're taking care in which there is a mismatch in the dimension, we increase the dimension, mismatch in the size, we increase the dimension. So we see here 2 comma 1 comma 2 and 1 comma 3 comma 2. You'll find the difference between them. Okay, so this minus 1 minus 2 is the difference between this guy and this guy. This minus 3 minus 4 is the difference between this guy and this guy, this guy and this guy, right? This is all about this point. This is the next one is all about this point. Okay, I hope everybody understood, some fundamental concepts of NumPy and towards the end of it broadcasting. That's all from this video. Thank you everybody.